Hello everyone, this is Chem Bonding tutorial question 5b. Okay, we have done 5a considering the shapes and the dot cross diagram. Okay, we are going to use 5b to explain the shape of the molecule. Okay, 5b says using VS-EPR theory, explain the shape of IOCl3. Okay, so we have drawn IOCl3. Okay, I is a center atom with O and the 3Cl as the atom surrounding it. And there's a lone pair of electron on I. Okay, so how do we describe the shape? Okay, so this is what we do. Remember, in the lecture, I mentioned that the first thing to mention is the number of bond pairs and lone pairs. So as you can see here, we have 1, 2, 3, 4 bond pair and 1 lone pair. Okay, so 4 bond pairs, 1 lone pair around the center atom I. Okay, and these 5 electron pairs, to minimize repulsion and to maximize stability, they are directed to the corners of a trigonal bipyramid. That's the basic shape. Okay, because of the presence of a lone pair, okay, the lone pair bond pair repulsion is stronger than the bond pair repulsion. Therefore, the shape is a distorted tetrahedral. Okay, and the bond angles, this bond angle will be less than 120 degree, and this angle between the axial and the equatorial position will be less than 90 degree. Okay, so that's for question 5b. Okay, now we move on to question 6. Okay, question 6 are some of the special cases that you can see in some of these molecules. Okay, question 6a wants you to compare the bond angle of NH3 and pH3. Okay, NH3 has a bond angle which is bigger than pH3. Okay, if we were to draw the shape, this is our pH3 and this is the NH3. Okay, what is one thing that you observe and notice about these two shapes? Do you see that they are the same shape? Okay, the name of the shape is called trigonal pyramidal. Okay, so since they have the same shape, why is it that this bond angle is smaller? The bond angle given is 94 degree and in ammonia is 107 degree. Okay, remember in the lecture I mentioned this has to do with an important factor concerning the center atom, okay, which is the factor of electronegativity. Okay, ammonia is more electronegative, so the bond pair electrons are drawn closer to itself. Therefore, there is a greater repulsion as compared to in pH3, the bond pair are further away from the center atom. Therefore, there's a smaller repulsion. Compared to ammonia, there's a bigger repulsion. Okay? So first we'll describe the shapes of the two molecules. Okay? Then we will talk about the electronegativity. N being more electronegative than P, the bond pairs are drawn closer to N. Okay, and hence it exhibits greater repulsion compared to that in a pH3. Alright, now we move on to another interesting case. Okay, you're supposed to draw the dot cross diagram for NO2 and O3. Okay, then they say that in each of these molecules there's a dative bond. Okay, suggest a value for the bond angle for each of the two molecules. Okay, and give reason for your choice. Okay, so let's first draw the two molecules. NO2 I remember drawing it in the lecture. Okay, NO2. I think there was some student who suggested that NO2 is has a double bond with O. Okay, but remember, we run into a problem. The problem of having more than 8 electrons surrounding N. So it cannot be both are double bonds. Okay, so I think we have gone through this and figure out that there should only be one double bond and one daisy bond surrounding O. Okay, and this is the structure of NO2. Okay, the dot cross in the structure. And for O3, we have O, O, O. Okay, if we were to try the same method, double bond, and let's say a daisy bond, okay, we check for each of the atom. Okay, for the center atom O, 2, 4, 6, 8. Okay, so it has achieved octet. For this atom O, 2, 4, 6, 8, achieved octet. And the last atom O, okay, it has also achieved octet. Okay, so this is a dot cross diagram for ozone, and this is the structure. Okay. This is ozone. Okay, my apology. Okay, so ozone here, and the NO2 is here. Okay, so they want you to compare the two bond angles. This bond angle and this bond angle here. Okay, first let's establish the shape. What are the shapes of these two molecules? I think it's not difficult to see that they are bands, right, about the center atom. Now remember, with the two bond pair and one lone pair, what is the bond angle? Okay, your book gave it as less than 120, correct? Because if it's 3 electron pairs, it will be 120. But if it's 2 bond pair and 1 lone pair, it will be less than 120. And we gave a value of 119. Okay, but how about this one? This is what we call a lone electron, a radical. So will you expect this bond angle to be more than 120 or less than 120? Okay, of course it should be more than 120, because a lone electron and a bond pair repulsion should be weaker than a lone pair bond pair. Okay, so it's more than 120. You need to suggest a value, for example 130 degree. Okay, alright, so this is how I will answer the question. Okay, for ozone, it can be any value between 110 and 119. Okay, for NO2, it can be a value that is less than 170 but more than 120. Okay, so example 125. Okay, the reason is because the lone electron bond pair repulsion as compared to the lone pair bond pair repulsion, okay, is weaker. Okay, part C. Antimony group 15 element, it forms an anion SbF5 N-. Okay, N is the charge. Okay, and they tell you that the shape of this anion is square pyramidal. Okay, you're supposed to deduce the total number of electrons around antimony and calculate the value N and the oxidation number of antimony in this ion. Okay, how to start? Alright, do the things that the question has provided you information with. Okay, we know that this is SbF5. That means there are 5 F surrounding Sb. Okay, and we know that there are Sb is in group 15, so there are 5 valence electron. Okay, one more thing we know is the shape, square pyramidal. Okay, square pyramidal means that there are 5 bond pairs and 1 lone pair. Okay, so we can draw it. So we have Sb, F, 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 and a lone pair here. Okay. We know that Sb has 5 valence electron. Okay, but let's count the number of electrons. Two electrons are the lone pair. And that means the number of bonding electrons contributed by Sb can only have 3 more, which means that this 3. 1, 2, 3. Okay, the other electron comes from the fluorine. Then how about these 2 fluorine? These 2 fluorine, what is the type of bonding? Okay, Sb have no more electrons. 3 electrons used for bonding, 2 electrons are the lone pair. It's lone pair because the shape is fixed for you, it's a square pyramidal that requires a lone pair. Okay, that means these 2 must be your dative bonding. Okay, the electron comes from your fluorine. And how come fluorine can give a dative bonding? Because fluorine will have received additional electrons from external, okay, which is from here, the charge. So 2 of the fluorines have the additional electrons. That means your N must have a charge of -2. Okay, so you must have a charge of -2. So N is 2. Alright, and what is the oxidation number of Sb in this structure? Okay, let's do a simple calculation. Okay, we use X to represent oxidation number of Sb plus the 5 F minus. Okay, the whole thing equals to 2 minus, therefore, 5 of them. Therefore, X equals to plus 3. So antimony has a charge of plus 3. Okay. Okay, moving on to question 6. Okay, question 6 is quite similar to the lecture notes example. We have here FO2 does not exist, but ClO2 does. Give 2 reasons why using a bonding in these 2 compounds. Okay. Okay, if we were to draw the structure, ClO2 would have a structure of this. Double bond, and then we have lone pair, and then unpaired electrons. Okay, this is a structure of ClO2. Okay, but it's not possible to draw FO2 like this. Right? If we were to draw FO2 like this, let's count the number of electrons surrounding F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it possible? No. Okay, the reason is because F being in period 2 is not able to expand its effect, whereas ClO2 it can. Okay, because of the energetically accessible d orbital. Okay, here we emphasize because period 3 elements can reach the d orbital to expand its effect. Okay, but FO2 cannot. Okay, another reason why FO2 does not exist is that even if we can draw it, we will draw dative bonds to O, which is not possible. because